Okay, what's up, Year 11? I want to talk to you about transistors, make sure that everybody understands them. So hopefully if you haven't got it yet and you got this wrong in your exam, this will help you out. So let's take a look at this question. Question 10, Part A, Part I, says, with the letter X, label the component that detects the change in external light intensity. So you're looking for the light-dependent resistor here, which is this object. You can tell it's a light-dependent resistor because it's got the arrows falling on it, which represents light waves. Letter Y, the lamp, everybody should get that, it's this thing. And finally, the letter Z, which is the component that switches the lamp on and off, it's kind of the logic part of the circuit, is this bit here. And if you remember, that thing is called a transistor. So those are 3 marks there, and then the next question here, Part B, is another 3-mark question. It says, describe how the circuit works as the external light intensity decreases and the lamp comes on. So what you've got to realise here is that this is a series circuit. If you look at this resistor and this light-dependent resistor, these guys are in series. So if the resistance of one of them increases, then the voltage share across that resistor increases as well. So what we've got to look at is that for a transistor to work, we need there to be a big difference in voltage between this part of the wire and this part of the wire. Now if there's going to be a big potential difference there, that means there has to be a big potential difference between here and here. So that means that the light-dependent resistor must take a large portion of the voltage, which means it must have a really high resistance. So we've got to think about how the resistance of a light-dependent resistor varies. As more light falls on the light-dependent resistor, we get a decrease in resistance. Okay, so when it's dark, the resistance of this thing is very, very high. That means that there's a big voltage difference between here and here. That means there's a big voltage difference between here and here. So the transistor turns on. Current is allowed to flow through here, through the bulb, and the bulb is on. So the important thing is when it's dark outside, this resistance is big, the transistor is on, so the bulb is on. When it's bright outside, then the resistance of this guy falls quite a lot. And so that means that these two in series, this resistor here is now going to get a bigger proportion of the voltage. So there's not a big potential difference between here and here. So that means the transistor is off. It doesn't allow current to flow through it. You know, the current's going to try and get through and it's going to kind of stop here. And so the bulb will not light. And that's pretty much the solution to the 3-mark question in Part B. Alright, so I just thought it'd be good to take a look at the mark scheme for this. So let's get rid of the question and bring the mark scheme in. Look at the 3 parts. So we've got the LDR, the lamp, and the transistor correctly identified. Pretty straightforward. And here are the 3 marks for the second part of the question. The resistance of the LDR becomes high. Okay, that's because the light has dropped. The LDR gets a bigger share of the voltage, so the transistor turns on. You can see that's a much simpler explanation than the one I gave. Hopefully my explanation allowed you to understand what was going on here and would allow you to apply this concept to different situations. Hopefully you understand that, and if you've got any questions, please leave them in the comments on Edmodo. Have a good weekend. Mark scheme for you. You can see LDR correctly identified, that's that bit. Lamp correctly identified and transistor, as we did. And then here are the 3 marks. The resistance of the light-dependent resistor becomes high. That's as it gets dark. It gets a larger share of the voltage. The transistor turns on. So what I've given you is a much more detailed explanation, but it's important to understand how this works, and that means that you can apply it to different situations. You can see at the top there, this is from November 2008, Paper 3. Hope that helped. Thank you.